In this session, we are going to understand the SR latch. So what is SR latch? SR latch is a logic circuit component. A logic circuit component is a circuit made of logic gates and it does a specific operation, control activity or it store value. For example, if you take an adder, it does a specific operation. If you take encoder or decoder, so they are capable of doing some control activities. So when it comes to a latch or flip-flop like SR latch, so they are capable of storing a value. So we can subdivide the logic circuit components into two: the combinational logic circuit components and sequential logic circuit components. So what is a combinational logic circuit component? A combinational logic circuit component is a logic circuit component that the output depends only on the input and it does a well-defined task. It does not depend on the current state or the memory. So whenever we give a specific input combination, the output is always the same. So therefore it is very easy to understand a combinational logic circuit component like adder, encoder, decoder, because we just have to look at the snapshot of that particular time instance and the input combination and the circuit to understand the output. So the logic components like adders, decoders, encoders, multiplexers, so they are all combinational logic circuit components. Let's just briefly look at one of the combinational logic circuit component, that is decoder. A decoder is a logic circuit component where we have n number of inputs and 2 to the power n number of outputs, and by giving different input combinations we can enable exactly one of the output. So these are the inputs and these are the outputs. You can see that for the different input combinations only one of the output is enabled and all the other outputs are 0. So this is a 2 to 4 decoder. So if you analyze this input output combination using the sum of product or the product of sum or any other approach, you can come up with a circuit. So it is not that difficult task understanding a combinational logic circuit component. Now let's look at what is meant by a sequential logic circuit component. So when it comes to sequential logic circuit component, the output depends both your input and the current state or the memory. So therefore, for a sequential circuit component, when you give the same input combination, there's a possibility of you are getting different outputs because it depends on the current state as well. When it comes to getting to the final state, you have to look at a sequence of steps in order to understand what is going to happen at the end. So that is why we call them sequential circuit components or sequential logic circuit components. And you can see that a sequential circuit component has set of combinational parts plus there is a self loop. So your output is fed into the input. So that is why we say that the output depends on not only the input but on the current state as well. So what are the useful sequential logic circuit components? The latches or the flip-flops, the shift registries, counters. So those are some widely used sequential logic circuit components. So let's look at what is meant by latch or flip-flop because we are interested in SR latch in this particular session. A latch or flip-flop is a logic circuit component or it's a sequential logic circuit component which is capable of setting to a value or setting to 1 and also resetting to 0, and also it is capable of remembering or storing that value, the 1 value or the 0 value. So that kind of a sequential circuit is called a latch or flip-flop. So you can see there are two words, the latch and flip-flop. So objective wise, they are the same. Setting, resetting and retaining the value. But when it comes to the operation and the functionality wise, they are little bit different. So latch is the basic component and flip-flop is the more complicated and advanced component. Let's look at the literal meaning of these two terms as well. So in literally, latch means something like a lock. So lock is capable of retaining something. So that is why they have given it the word latch. And I told you that flip-flop is more compound or more complicated and more sophisticated device. So basically flip-flops are made of couple of latches. So that is why they have used the word flip-flop. So we use the word flip-flop for pair of slippers. So flip-flops are also made of pair of latches. In this session, we are only interested in latches for two reasons. The first one is the latch is the component that is easier to understand. The second thing is, in order to understand flip-flops, first we have to understand latches because flip-flops are made of latches. There are different type of latches. The SR latch, S-R dash or the S bar R bar latch and the D latch. So those are the more widely used latches. Here we are interested in the SR latch, the basic latch. So let's look at what is SR latch is. Because SR latch is a latch, we can set the value to 1. We should be able to reset the value to 0. And the latch must be able to retain or remember the value. So in the case of SR latch, we use 2 NOR gates. And you can see that the arrangement is little bit fuzzy because the output of the first NOR gate is one of the input to the second NOR gate. And the output of the second NOR gate is one of the input to the first NOR gate. So that is what make it little bit complicated. So if you look at the overview of SR latch, so we can reset the latch into 0 by providing the input combination SC equals 0 and R equal 1. If we want to set it to 1, we have to give SC equal 1, R equals 0 input combination. And the value will be retained by the latch when we provide the 0, 0 input combination. Oh, that is where the memory or the retention. And there's another important thing when it comes to SR latch, that is we must never give the 1, 1 input combination to the SR latch because it results in invalid situation. So if it move on to the 1, 1 situation, we have to clear the latch again. So let's try to understand how these things are happening at a conceptual level using our understanding of logic gates. And also when it comes to SR latch, so there are 2 possible outputs. If you have set it, the output must be 1. If you have reset it, when we read, the output must be 0. But you can see it's not just one output. There are 2 outputs. Actually, we are only interested in the first output. We call it Q. And Q bar is just a supporting output to have the functionality. And also there's a rule. Whenever your Q output is 1, the other output must be 0. When your Q output is 0, the other output must be 1. Or it must be the inversion. So therefore, we just call the first output or the output that we are interested as Q, and we just call the other output as Q bar, because that is only if you get the inversion as the second output, this latch is going to properly function. And if we get 1, 1 or 0, 0 as the output, we say that the latch is in an invalid situation, because it has violated that basic rule. So when this is Q, this must be Q bar. If both are 1, that is not the case. So in that kind of a situation, our latch is not going to give us the required functionality. So let's first look at how we can set and let it remember the set value of 1. So if you make that latch get the 1, we say we set it. And once we set it, since we want to make a memory cell, it must be able to remember it as 1. So therefore it's two-step process. We set it and we let it retain. So how to set the latch into SR latch into one state? So we have to provide SC equal 1, R equal 0 input combination. So that is why this SC is called S, because it sets. And in order to retain it, we have to maintain SC equals 0, R equals 0, R equals 0 input combination. So then it is going to retain the set value of 1. First, let's look at what happens when you send SC equal 1, R equals 0 combination and check whether is it really going to set it to 1. Now this is SC equal 1, R equals 0 combination. And we have the two NOR gates and the two outputs. So in order to easily understand the output or visualize the output, we have represented the two outputs with two bulbs. Now, because we are using two NOR gates, in order to understand the SR latch, it's very important you refer to the truth table of the NOR gate. And we know that in OR gate, when at least one input is 1, it is 1. And when both are 0, only 0. But this is not OR gate, this is NOR gate, so therefore inversion. So when at least one input is 1, the output is 0. And when both are 0, only the output is 1. So we have to keep that in mind whenever you analyze the SR latch. Okay, now let's look at what will happen when we provide the input combination SC equal 1, R equals 0. So this is the fuzzy area where when one input is 0, we can't determine the output without knowing the second input. Still we don't know what is the second input is, because that is the output of the other gate. But when you look at this side, you can see that when at least one input is 1, it is guaranteed the output is 0. So therefore, this output is definitely 0, because when at least one of the input is 1, the output is 0, and we know that one of the input is 1. We don't care whether this is 1 or 0. Guaranteed that the output is 0. So now this output is fed it to the other NOR gate. And now we know that both the inputs are 0. Earlier we were not sure. It was fuzzy, but now it is clear. So now both inputs are 0. When both inputs are 0, the output is going to be 1. And now this 1 will be fed it to the other input of the second NOR gate. Now anyway we know that when at least one input is 1, the output is 0. But now we know that both are also 1. So anyway it is going to be 0. So therefore again it is going to be 0. Then that 0 is going to be fed it to the other NOR gate. And therefore the 0, 0 combination results in 1. That 1 will be fed it here. And 1, 1 combination is going to result in 0. And you can see that after few seconds or few nanoseconds of electricity flow, this SR flip-flop is going to saturate it into output of Q as 1 and output of Q bar as 0. And that is what we need, because we want to make sure that when you check the output, we want to make sure that you are getting 1. So that means the latch saying that I am currently having 1. If you just keep retain the SC equal 1, R equal 0 combination, this is going to retain the value 1. But what we are going to do is, we set it using SC equal 1, R equal 0, and we are going to release it. So we are going to make both the inputs 0 and see whether it can still retain the value of 1 or keep the Q as 1 and Q bar as 0. So in order to understand that, first we have to understand that just before you make both 0, what is the output combination? Q1, Q bar 0. And in such a situation, we are going to make both 0. So now let's see what happens when we set when we make both R and S 0, by the time this one is 1 and this one is 0. Right, now we have made both 0 because we want to see whether it can retain it, and by the time this output is 1 and this output is 0. So when this output is 1, so it will be fed it here. And we know that when at least one input is 1, the output is 0. So therefore, this output is going to be 0. And anyway, before that movement also, the output was 0. And this 0 is going to fed it to the first NOR gate. And we know that when both inputs are 0, the output is 1. So therefore, even when we release both the charges, or both we made 0, still it is going to saturate it to a situation where the Q is 1 and Q bar is 0. And again Q is fed it here. When at least 1 is 1, it is 0. And this 0 is fed it here. When both are 0, it is 1. And it is again saturated to Q equal 1, Q bar equals 0. So that means even when you make it R equals 0, S equals 0 situation after setting, this is going to stay in the same state. So now we say that the latch has remembered its value of 1, or the set value. Now we are going to look at how can we reset the SR latch to 0. So when we reset the SR latch, we have to provide R equal 1, S equal 0 input combination. So that is why we call the second input as R, because it reset. And also, in order to retain it, we are again going to take it back to the 0, 0 situation. And let's see whether it can retain the reset value. Let's first see whether we can reset by sending S equal 0, R equal 1. Now we have get into the situation where reset to the R is 1 and set is 0. Now again we have to refer to the input, the truth table of the NOR gate. When at least one input is 1, the output is guaranteed to be 0. So therefore this is going to be 0. And now we know that this is 0. Now we can determine what is going to happen here. When both inputs are 0, the output is guaranteed to be 1. And that 1 is fed it here. And we know that even when both are 1, the output is 0. And that 0 is fed it here. When both are 0, the output is 1. And it's going to be saturated into the Q equals 0, Q bar equal 1 state. So that is why we call it sequential circuit. So you have to think through set of sequence to understand, is it going to be saturated into a stable state, and what is that state? So that is how we reset, by sending R equal 1, S equal 0 combination. If you keep using the R equal 1, S equal 0, yes, it's going to retain it as reset state, or the Q0, Q bar 1. But let's see what will happen if you make both R and S 0, and still can it retain the value as 0. Now by the time, remember, your Q bar is 1 and Q is 0. So that is something we have to remember, right? Now our Q bar is 1 and now Q is 0. We have made both 0. And this 1 is fed it here. So when at least one input is 1, the output is 0. Anyway, the previously also the output is 0. Now therefore, this is going to be 0. And that 0 is fed it here. When both are 0, the output is 1. So therefore, yes, it is going to be 1, and that 1 is fed it here. When at least one input is 1, the output is 0, and this is going to saturate it into the previous situation again. So therefore, even when the both inputs are 0, still it is going to retain it as 0. So that means when you set it and make both S and R 0, it is going to remain as 1. If you reset and if you make both S and R 0, it is going to remain in the reset state as well. So therefore, this gives us the functionality of a memory cell. So we can reset it to 0 and retain it. We can set it into 1 and retain it. Now let's get into an interesting scenario. So what will happen by any chance if you make both S and R into one state? And again, let's refer to the truth table of the NOR gate. And we know that when at least one input is 1, the output is 0. So therefore, this is going to be 0. And here also one input is 1, and this is also going to be 0. And now this 0 is going to fed it to here and it becomes 0, and this 0 is going to be fed it to the first NOR gate. So anyway, it is not going to change anything. When at least one input is 1, the output is 0. So therefore, when you make it both S and R 1, it is going to result in both Q and Q bar as 0. So that has violated the basic principle of the latch, where the one output must be the inversion of the other output. So therefore we say that for SR latch, S equal 1, R equal 1 combination is an invalid combination. So that is not going to be the invalid for all the latches, but for SR latch. And that is one of the drawback of SR latch as well. Setting both S and R into 1 is resulting in an invalid situation. Right. So I hope you have understood what is SR latch is. SR latch is made of 2 NOR gates. We can reset the SR latch at any time by sending R equal 1, S equal 0. We can set the SR latch at any time by sending S equal 1, R equal 0. And we can let it remember whatever the current value by setting both S and R into 0. And we must not let both S equal 1, R equal 1 situation, because it results in an invalid scenario. Right. So we mentioned two words when we were discussing when we mentioned about the sequential circuits, the latch or flip-flop. I told you that the latch is the basic component, the flip-flop is the more advanced component. The latch is made up of the simple logic circuits, whereas the flip-flops are made up of the logic circuits plus our existing latches. So let's compare the differences between latches and flip-flop. So latch does not use the clock signal, whereas the flip-flop, we use it with the clock signal. So you can clearly see that just two inputs are there, S and R. But when it comes to the SR flip-flop, we have the S and R plus the clock signal. So I will explain what is the purpose of this clock signal when we are discussing the SR flip-flop in another session. So first, but you have to understand that SR latch does not use the clock signal, whereas the SR flip-flop use the clock signal. And also the latches are made of simple logic gates. Flip-flops are again made of logic gates, but it contains internally latches as well. Of course, the latches are again logic gates. So therefore, flip-flops are more complex logic circuit component. And both can serve as memory cells. But when it comes to latches, we use latches as a memory cell in asynchronous circuits. So asynchronous means the timing is not important. Whereas we use flip-flops as a memory cells in synchronous sequential circuit. So there are situations where latch is good enough, and there are situations the flip-flop is needed. And also latches are level triggered devices, whereas the flip-flops are edge triggered devices. So what is mean by level triggered device? Whenever you change the input, immediately the output change. Of course, it needs that saturation time, but it happens immediately. But when it comes to flip-flops, the output change when you change the control signal. So that is another difference between latch and flip-flop. Of course, we are going to understand those things when we are discussing the flip-flops. But this is just an overview or some insight into the flip-flop as well. And also latches are susceptible to noises. So whenever you change some input, or at least by accident, it may result in some invalid situation. Whereas flip-flops are more stable devices, because the flip-flop output change when the clock signal change, not when the input is changed. And some example of latches are the SR latch, which we discussed right now, D latch, S bar, R bar latch, those are some latches. Whereas when it comes to flip-flops, again we have the D flip-flops, a JK flip-flops, which is sort of a variation of the SR latch, etc. So I hope you have understood the SR latch perfectly, and this is good time to think about the next steps. So there's another latch called S bar R bar latch, which is made using two NAND gates rather than using two NOR gates. The circuit is exactly the same, other than you replace your NOR gates with NAND gates. And it's good time to analyze the S bar R bar latch and see how we can set it, how we can reset it, how we can make it into a remembering state or memory state, and are there any invalid situations. So you should be able to analyze it by yourself now, and then refer to some tutorial or something and see whether your understanding is correct. So the second task that you can do is, if you are familiar with the breadboard and bit of digital electronic circuit components like the ICs, resistors, push buttons, etc. So build a simple circuit of the SR latch we discussed and see whether is it really going to remember those values. So give it a try. The third one is learn how to make this SR latch into a gated SR latch, or we call it SR flip-flop. So that is your next step. And also try to understand what is D-latch is, because D-latch is just a variation of SR latch again. So think about those things and try to self-learn those concepts before referring to this next sessions that we are going to cover. Anyway, we are going to cover those things in the subsequent sessions, but it's good time for you to think about those things and try to understand it by yourself. So I hope you enjoyed this session and you understood the SR latch perfectly. And if you feel like you like it, make sure you like the video and also subscribe if you are interested in getting notification of the future videos. Thank you.